Good morning, everyone. Myself, Rohit Pathak, Assistant Professor in Mechanical Department of Rabindranath Tagore University. Today is the second and the last session of the workshop. For this, I would like to invite Mechanical Head of Department, Mr. Abhishek, for their valuable thoughts. Sir,
First of all, on the behalf of Mechanical Department, welcome all the participants and eminent speaker in this second day of two-day workshop. And I hope that this workshop will be very useful for us for our career and research purpose. And I also have that most of us will get very positive points from these workshops. I request Pathak sir to continue the session.
okay, sir.
Hello.
Hello.
Okay. Please
Now,
continue.
okay, sir. Okay. Now,
Yeah,
I would like to welcome Amit Abbas, sir, from MPRI Bhopal. First of all, I would like to introduce Amit Abbas, sir. Dr. Amit Abbas, sir, is a mechanical engineer and has done PhD from engineering science, material science, and
रोहित
technology.
सर इको आ रही है थोड़ी सी अगर वो हट सके तो
Okay, sir. Okay, I'll be checking.
okay.
हाथ में लेके बैठो।
hello.
Hello,
Yes, hello.
audible, sir.
हाँ ठीक है हाँ क्लियर आ रही है बोलिए बोलिए सर
Okay.
Uh,
I would like to welcome Amit Abbas, sir, from MPRI Bhopal. Let me introduce Amit Abbas, sir. Dr. Amit Abbas, sir, is a mechanical engineer and has done PhD from engineering science, material science, and technology. And he has cleared GATE 5 times and is a rank holder in CSIR NET 71th rank and published total number of paper publication. It has 10, which is having the total impact factor of 33 and has won the Research Ratna Award in 2019. So I am mostly heartily welcome to Amit Abbas, sir, and I would like to share their valuable knowledge from the point of view. And today he is giving the uh, topic on research methodology and importance of characterization. So I would like Amit sir to share their knowledgeable thoughts. Please, Amit sir.
yeah, thank you, sir.
Okay.
Yeah, first of all, I would like to welcome all of you in this session. And in this session, we are going to discuss about that what should be the procedure that we should follow before conducting a research and before we are organized to conduct a research and how we should proceed. That means in terms of the fabrication of and a collection of all the data in a sequential manner so that we can discuss it in very brief that how can we achieve some positive result during the research. So this is the organization of this lecture, that what is the research in very brief. I would like to discuss it, then define the statement problem and how we can recognize the gap in the research field, and then selection of the materials and methodology. How can we select it and how we should select the material, and then we have to select the method on the basis of the material we have selected. So then after selecting the material and methodology, then we'll go for the selection of fabrication process. And then after selection of the fabrication process, then we will fabricate the samples, and then according to our application, we will go for the selective characterization. Then what type of we have a requirement of a property, and what is the area of concern of ours, So on the basis of that, we will select the characterization process, and then we will collect the data. And the main thing is that up to this point, this is all right, but analysis of the result is very important. So we will analyze the data, and how we can analyze the data, this is the most important thing. Then we'll go for the discussion and conclusion. This is, and how we can draw the conclusion, this is also a important part of this lecture. So will and I would like to connect my research work that I have performed. So I would like to connect the a generalized view into my area of concern by giving just an example. So at first, just a definition of the research process, that the research is a process of step that users establish to fund. Just 1 minute. Yes. Is a process step used to collect and analyze information to increase our understanding of a topic or issue. This is just John W. Creswell statement. So this is just a classification. I just have taken one classification. Various classification you can see the basic and applied. Basic means fundamental. You are developing a fundamental result, that is a basic type of research. And on the wherever the you are conducting a research by using some another fundamental, then that type of result will be the applied in the category of applied applied type of research. This is just a stepwise formulation of a research work. So detailed literature survey. At first, before conducting any research, the detailed literature survey is required. Means at first you should go through the some previous papers, previous literatures. This is the most important thing that we should follow. That means ample number of papers you should read. The previous papers you should go through. Then on the basis of data you have collected, then you should go for the problem statement. Then you should draw the problem statement, that what type of research gap you have found in that paper. Means what the work they did not have done, that you have to find out. And then you have to select your own goal, that formulate the goal and your objective. What will be your objective? That is also an important part. So then after you have to plan and design the research, then what type of instrument you required, what type of setup you required, then what should be the procedure, then these type of things you have to just formulate it. And then you should go for the fabrication of the process. So then after you are just fabricating the sample, and then you should go for the characterization of the sample, collecting the data analysis and generation of the result, then interpretation of the result and conclusion, as we have discussed it. So problem of statement, how we can see the problem of statement. What is problem of statement exactly? Just in very brief, we are going to see this one. An area of concern, a gap in the knowledge, a gap in the existing knowledge, or a deviation in the norm or standard that point to that need for further understanding and investigation. That is the actually research. And from here the main part is, I think, this one. At first see the problem and then do the solution. This is the exactly result is all about, research is all about, sorry. So just an example I'm going to see here, that the human bone. For example, I have taken, since I have taken it from my own research work, that's why I've taken this one. So as we can see that in this era, a lot of accidents and took place due to high speed vehicles and road accidents we have seen in our daily life. So fracture of the bone is a generalized issue, especially I'm talking about this long bone. This is femur, and this one, this bone is a tibia. So this femur or tibia, especially, and this one also, the long bone, these got fractured in our. We have found in our study that these type of fracture of bone takes place. So just so this is the development of bone. So we have to design the material for that bone, means the bone that got fractured, we have to select the material, and we have to replace that fractured bone with the artificial prosthesis. So before we are going to implement our research work and we are going to conduct, we should know that how bone is developing. Means as there is a factor of age also in here. So in the embryo, you can see that here in the first, this is the development of the bone, and stage-wise development is here. So in the first image, you can see that here there is very less porous part present in this the first bone. As we are the age is increasing, this liquid part of the bone is decreasing, whereas this porous part, the porous or solid media is got increasing. And here we can see that in adult person, the cancellous, this net shape structure is more as compared to this liquid bone, liquid part of the bone. That's in fact we can say it as the softer tissue. Okay, so here there are two more things we should focus, that this portion is having more porous part as compared to the inner part. Inner part, here we can see the solid portion is more. This is called the cortical part of the bone, and here this is the cancellous bone. The cancellous bone is having more porosity, as we can see, and here it has the lesser porosity. But what is the difference? So difference is that here this is the cortical bone, and this right side is the cancellous bone. This is the rigid part of the bone that gives the strength to the body structure. Initially, it may take, as I am discussing this cortical bone and bone type, the person who is not doing the research in the bone direction, he may got confused with this one. But after few slides, I will connect all these things and compile the data so that you all will understand that what is this, why I am discussing these things with you. So the rigid part of the bone that gives strength to the body, that protects the inner organ. Obviously, if this is the rigid part of the bone, definitely the strength will be higher, and this will give the stiffness, total stiffness and stability to the entire body will be given by the cortical part. Whereas in a it has low porosity. Low porous media means porosity if low, then density must, it has more density. Okay, so generally less than 30% porosity it has. Whereas in the cortical bone, 170 megapascal strength will be higher as compared to this cancellous bone. Young's modulus in the range of 3 to 30 GPa. Here in the inner part, this is the inner part of the bone, as we have seen that the transport of the body fluid and tissue growth takes place due to porosity. transportation of the body fluid and tissue growth will take place through the cancellous part of the bone. A highly three-dimensional interconnected porous structure, generally more than 30%, in fact, up to 70%, 80% porosity the cancellous bone has. So this is also the area of concern that mainly, and this is the main challenge to design a artificial bone. So now, how I got this one? By going through the literature. That's why I told you that in the research methodology, the main thing is that you have to perform the mainly literature survey. And after going through the literature survey, I have concluded these points that no, the cancellous bone is the main part of concern. See how the compressive yield strength is about only 2 to 60 megapascal. This is not the issue. Generally, if you are using a material, a metallic material, definitely you will get this much strength. But the problem is here. The Young's modulus is only 0.1 to 3 GPa. Such a lower Young's modulus and this strength we have to achieve. Otherwise, this Young's modulus is nothing but the stiffness. Stiffness is what? As a mechanical engineer, how can we define the stiffness? Stiffness is load per unit deflection, load required to produce unit deflection. If stiffness of the bone implant that you are putting inside a human body will be different from the bone, so the deflection will be different due to difference of Young's modulus. So that will just loosening of the implant will take place due to difference of Young's modulus, and this will produce the stress shielding effect, and this will generate pain inside your body. So we have to match the property of the artificial implant with that the artificial means that with the natural bone. So just by going through the literature survey, I have concluded this one. So on the basis of these things, I have drawn my problem statement, and on the basis of this one, these points must be noted that the bone resorption is the main issue that occurs due to mismatch of the Young's modulus of the replica and bone, human bone. And this is mainly due to Young's modulus, because strength is not the issue. We can easily achieve the strength in the metallic material. This is about 60 to 70 or within 200 megapascal. 70% of the replantation are caused due to bone resorption only. In fact, I should say that this more than 80% and 90% of the bone retransplant are caused due to bone resorption only. Compressive yield strength is lower. And now, what is the main challenge? The existing in the previous artificial bone, what we have seen that stainless steel type of structure they are using. So also there is a problem of proliferation of the body fluid. The body fluid that should flow through inside the artificial implant. So their need of the porous type of structure we need. So these things also I have concluded on the basis of literature survey again. So now you can see that what is the significance of literature survey that we should go through. So these things, the bone resorption 70%, compressive yield strength is low at higher porosity, and also there is a problem of erosion takes place due to rubbing action between the joints. As we are moving, the artificial implant will also get rubbed with the adjacent component. So due to that rubbing action, erosion will take place, and due to that one also the life of the implant will get reduced, and after certain period of time there is a need of what to replace the present implant with the new implant. So this was also the problem. So and lack of interconnectivity among the pores, so that no proliferation of the body fluid takes place. As I have discussed, that porosity needed so that the blood cells can grow into that that artificial implant and these things. And there is also a problem that with the steel based implant, that replica corrodes in the body fluid. In fact, these are the also problem with the with some of the existing new implant also. These are the problem that we have recognized during this. Mainly, this is how you can draw your conclusion. Means a problem statement. Now, after I have selected the problem, that what is the research gap? I have seen the research gap. Where is the research gap? And then on the basis of that one, just I have selected the material. Then I have gone through the again literature and hello, hello.
Hello.
Yeah, am I audible, sir?
Yes, sir. Audible.
Yeah, okay. Thank
Okay,
you.
sir.
Sir, yes, sir.
Yeah,
Audible.
okay. So, selection of the materials and methodology and fabrication. This is the most important section. That what I have chosen on the basis of that literature survey I have gone through. So, when I have seen so many elements and metals, then I found that titanium is a lightweight. The density is about 4.5 gram per cc and having high specific strength, comparatively lower elastic modulus. I'm comparing it with the stainless steel that about 210 GPa. This is almost half, 1110 to 1116 GPa, and strength is also comparable. And in fact, specific strength is higher. So also low cytotoxicity, non-carcinogenic, and biocompatible material. This is the most important properties of titanium. That this titanium is widely used these days for the bone implant application. So this is, I'm just connecting it with my research, but on the basis of your own research, you can select the material. And also the area you are concerning. For example, if someone is conducting a research in the field of solar power panel, so then you have to go for the semiconductor and all. Then what type of semiconductor you can go for and how you can select it. So these type of things you should go through, and you should go through that type of literature. That yes, this literature survey, and this one may be important for you. Now, as I told you that the titanium is while I have selected this titanium, there is a need to generate the porosity in this one. So as I will generate the porosity, so the due to porous type of structure, due to generation of the porous type of structure, the overall strength of the implant, yeah, overall strength of the material that we are going to develop, the strength will be reduced drastically. Drastically there will be a reduction in the strength. So we have to increase the strength by maintaining the porosity. So how we can increase the strength? By alloying some another element. So we have select the alloying element very carefully, and two options we have means I have found that there are two type of stabilizer, means two type of phase of titanium I have found. That one is alpha phase and another is beta phase. And the properties of alpha phase titanium is different than the beta phase. Now, aluminium, when I have gone through the literature, I also found that aluminium is a well-known alpha stabilizing element, that it will stabilize the alpha. And if we are stabilizing the alpha phase, more the alpha phase, machinability will be more. And if machinability will be more, then we can create a complex type of structure, as the bone has. Bone has a complex shape structure. So that's why I have selected this one, alpha phase stabilizing element, so that if alpha phase is more, then we can increase the machinability property, and some ductility will be also more, and some energy absorption capacity, and how we can achieve it, we'll see in the later stage. But these things are important while you are selecting the allying element. So and then the beta phase is also important. Why? Because beta phase has comparatively lower elastic modulus than the alpha phase. So we have to balance the both the phases by allowing different quantity of material, if we should say. So then cobalt based alloy. When I have gone through the literature, I also found that cobalt based alloy have also shown the biocompatible properties. Especially you can see in the vitamin B12, there is a cobalamin, the protein in which cobalt is an essential element. So up to certain limit, cobalt is biocompatible, but after certain limit, it will also produce carcinogenic effect. So we have to optimize these things also. So the cobalt based alloy I have selected, and also there is a coating of cobalt they have done. In the literature, if you'll go through, then you can see that the cobalt based coating they have done on the implant to increase the life of the artificial implant. So these type of things we have to produce on the basis of a single selected procedure and single selection of the material. So titanium, aluminium, and cobalt. Now I have concluded the material. Means I have selected the material. The first procedure is completed. Means at first gone through the literature, and on the basis of literature, I have selected the gap, research gap, and then on the basis of research gap that I have found, I have selected the material. That no, this material is suitable for, may be suitable for, because I didn't have got the result till now. That's why I can say it, that may be suitable. That after conducting the research, then we will be sure that no, this will be the definitely will be the beneficial, and we will definitely at the later stage, I have compared it with the natural bone also. So you will see that how it will be comparable with the natural bone. So here, and once I have selected the cobalt, aluminium, and titanium, then quantity is also important. Then what quantity we should mix it. So again, we have to go with the phase diagram. Then on the basis of phase diagram, we can see that we can select our quantity, that in what quantity we have to add the cobalt into the titanium matrix. Cobalt alloying element is an alloying element of cobalt, that in which quantity we have to add it. So mainly in the literature survey, you will found this Ti2CO here at 30. After 30, you can see here, this is the line of Ti2CO. This is, and this is here at here somewhere. This here at, this is the eutectoid point here. This before, I think the temperature may be around 670, 680, around 665. Okay, so this one. So I have to establish this one, Ti2CO. So when by applying the lever rule, as we can see, as a mechanical engineer, we know that by applying the lever rule, we can select the what? In which quantity we should select the Ti2CO so that the weight percent of cobalt we can get to get certain amount of Ti2CO. So on the basis of this one, I have selected it, and then to generate, as I discussed to you in the previous slide, that porosity we need to generate the porosity, and to generate the porosity we need to select the space holder. What is a space holder? We will mix it with the alloying element, and during heating it will get evaporated. It will get evaporated by leaving a vacant space that is called as porous type of structure. So in the present study, I have selected NH4HCO3 as space holder because of decomposition of NH4HCO3 takes place at lower temperature, about 36-degree temperature, and decomposition starts and finish about up to 100. It will be get ensured that no, completely this got evaporated, and it produces ammonia, carbon dioxide, and water. So this is the advantage. This will not left with any type of residue, so that it will get in effect the property of the implant, because ammonia easily get escaped out. This CO2 also is a gas easily get escaped out. H2O is just a moisture, and we will heat it during baking 150 up to 150. 100 after 100 the water is also get evaporated, and to ensure the complete evaporation of the water, we will heat it up to 150 degrees centigrade, so that the complete evaporation of the water will also take place. Means now we are completely sure that the complete evaporation of the this space holder, this is ammonium bicarbonate, ABC. So we have selected the space holder, the alloying element, and the matrix material, every material along with the space holder I have selected. And also one thing I would like to discuss with you, that the procedure is also important, as I have selected titanium as a matrix material, and the temperature, melting temperature of the titanium is 1670-degree approx. So 1670-degree, definitely two types of process we have. That one is liquid metallurgy route, and another is powder metallurgy route. So liquid metallurgy route we generally prefer for aluminium, magnesium, these type of alloy which has comparatively lower melting point material. But titanium has 1670 degrees centigrade melting point. So we will prefer the powder metallurgy route. And in the powder metallurgy route, space holder technique is the cheapest method to produce the cheapest and more command in the space pore size and cell wall thickness, more command we have. That's why we have selected the space holder technique. And in that technique, we have selected ammonium bicarbonate. Hello. Yeah, am I audible, sir?
Hello.
Yeah.
ये घनश्याम घनश्याम सर
Amit sir, audible it is.
घनश्याम सर आवाज म्यूट कर लो.
Kanchan sir, please mute your mic.
Yeah.
Sir, please.
Yeah. Sure.
Please continue, sir. Continue.
So on the basis of this one, I have selected the baking temperature. This is 150-degree to ensure the complete evaporation of water and moisture content. So now, after selecting the material, now fabrication is the important thing. That how we will fabricate it. So titanium, this is cobalt and aluminium in a proper proportion. At first, and this ABC is ammonium bicarbonate, this is NH4HCO3, this is space holder. So at first we have to mix it. We have to mix it. You can go for the mechanical mixing, or you can go for the simple mixing also. PVA is polyvinyl alcohol. You can add it, the polyvinyl alcohol solution, 2.5 weight percent generally. The researchers have preferred the 2.5 weight percent solution, in which the previous solution, if I am telling you, means 98% water, in which 2% PVA we will add it. The PVA solution, we are adding it to produce the green strength, means before sintering, if it should retain its shape. To produce that shape, we should add some additive. So that this is a just a additive PVA polyvinyl alcohol. We have just mixed it at first, and then we'll go for the compaction. And I have compacted at 400 degrees, 400 megapascal, sorry. This 400 megapascal also I have optimized it, and on the basis of this optimization, I have also published one paper. This is under review actually right now. So this is 400 megapascal is the compaction pressure I have applied on it, and then after compaction of the sample, we will go for the baking. And also one more thing I would like to discuss here, that the sample size. The sample size you have to select it by going through the standard ASTM. Either you can go for the ASTM standard or Indian standard, Japanese standard, European Union standard. A lot of standards are present, and aspect ratio on the basis of a standard you have selected, then you can select the sample size. And on the basis of sample size and percentage of fraction of the alloying element, you can easily fabricate these samples on the basis of volume fraction. And the amount of porosity, that if we have to produce the 40% porous material, then we will select the ammonium bicarbonate, means space holder, as 40%. Then somehow we can get 40% porous structure, means plus minus 5 maybe the deflection, but somehow we will closer to that one only. So after compaction, we'll go for the baking process, and after baking, the complete evaporation of the space holder will take place here. So now we are left with here, from here only just we have the metallic medium, means titanium, cobalt, and aluminium. And then to provide the actual strength, we have just we will go for the step sintering. This is just called the simple sintering, but I have selected the step sintering because of the completely completely dissolution, solid solution, so that the complete dissolution of the cobalt aluminium into the titanium matrix, so that we will get more and more strength at the higher porosity too. So this is also an area of research, that how we can select the sintering temperature and all. So one more paper I have published here, this effect of sintering temperature in material later. So here is the this is the furnace, and I have placed the sample here, and by selecting a proper sintering temperature in the vacuum sintering furnace. And also you have to maintain the vacuum so that at higher temperature no oxide formation takes place, because if the property of titanium and titanium oxide is completely different, and if you are adding aluminium, so if you will go through the aluminum diagram, so you can see that Al2O3, aluminium oxide, aluminium easily get oxidized as compared to the titanium and cobalt. So we have to ensure this one also, that no oxide should take place, because we have to command the every parameter, so to get the desired property. If any parameter within the fabrication process varies, this will affect the final property of the implant. So we have to select every parameter very carefully, and then after sintering process, polishing, and the pre-characterization process, means after before characterization, we will polish it, and we will Kroll's reagent agent will use, and then after we'll go for the characterization. I have just mentioned here 4 to 5, but I'll go through the 10 to 12 or 15 type of characterization. So we'll discuss it in the later slide. So the characterization, and from here we can see that what type of what is the significance of the characterization. And at first, the particle size analyzer. This will definitely the particle size is going to influence and affect the properties of the implant. So you have to select the particle size very carefully, and also the impurity, and means how pure the particle titanium powder or cobalt powder or aluminum powder, that will also affect the final property of your implant. Then scanning electron microscopy, micro CT scan, X-ray diffraction techniques, FESEM, this field emission scanning electron microscopy, energy dispersive X-ray spectroscopy, HRTEM, Raman spectroscopy, compression test, tensile test, fatigue test. So many tests here you can perform it, micro hardness. And then I have done the corrosion test, TOEFL, and all. So many characterizations are there, but I would like to discuss only mechanical part. So this is the powder synthesis. How we can see that what is the size of our powder, and how this will affect the properties of the implant that you are going to fabricate. So particle size analyzer. By using the particle size analyzer, you can see that what is the distribution of the particle and what is the average size of the particle. For example, this one is the titanium powder. So the average size, you can see this is comparatively lesser than the particle size of aluminium. Here this is the aluminium powder, and here you can see this is a coarser particle. I think titanium powder is a coarser particle than the cobalt particle, and aluminium particle is coarser than the titanium particle. This also we should select it by going through the literature, or you can prepare your own sample to see the actual effect that what you have found in your sample. So these type of things, and this IP is the irregular shape of particle. Here I have used the term IP. CP is the coagulated particles, and this SSP is the spherical shape particle. This SSP is the spherical shape particle. So if you are using a range of particles, so there may be a possibility of settlement of the particle in the voids, that if you are settling the particle in a proper manner, more area of contact in between the particles, if there, then better centering process will take place, because of the if proper contact, proper physical contact among the particle will be there, then more dissolution will take place, more better solutionizing of the solution you will get. So analysis of the particle or size of a metal and ammonium hydrogen carbonate was carried out to get the mean particle size of the titanium. And further, of powder synthesis I have written here. But as I told you, particle size analyzer will give you this diagram, this graph, volume fraction, volume percent in x-axis. This is particle size in micron. But this is a FESEM image, or scanning electron microscopy image. So again, we cannot rely only on one source. That maybe there may be some error on this one. So we have to confirm it by SEM image also. So by going through the scanning electron microscopy image, we can measure it and just descale it to get the confirmation that no, actually the particle size is this one. So these particle size were again confirmed from the SEM image of the pod. Now, after that, mixing of the powder, as we have discussed during the fabrication process, the mixing of the powder we are doing. So, we have mixed it, and to ensure the complete mixing, we mix it about 10 minutes, 10 minutes per sample or 15 minutes per sample. More the time you will give, more the accurate result you will have. So, to ensure this one also, overall mapping of the mixing powder you should do, and so that this overall mapping you can see that proper this red in the this red part is showing the titanium powder. Here you can see the aluminum powder, and here you can see the distribution of cobalt powder. So here we can see that how the distribution of the titanium, aluminum, and cobalt powder is mixing. So by going through the overall mapping of the powder, we can ensure that no, this is the proper mixing, and now we will get the desired result. So at each and every step, you have to confirm that no, whatever the procedure we are following, this is in a proper manner or not. If this is not a proper manner, you will not get the desired result. So this is the significance of characterization I would like to mention here, that if we will not characterize it properly, we will not be insured. Now, after we have baked it, and then we have just sintered it, and after sintering, we have to see that whether the complete evaporation of the ammonium bicarbonate took place or not. We have to ensure it. So to ensure this one, at first we have see the scanning electron microscopy. So various morphological properties we can obtain. Various morphological properties we can obtain by going through the SEM image, scanning electron microscopy image. The cell size, what is the cell size we have obtained? What is the cell, also the cell 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 structure, that what is the structure of the cell? What is the cell wall thickness? Cell wall thickness is nothing but the in between the two cells there is a wall. What is the thickness of that cell wall? That is also affected with the space holder size that you have taken in your study, and also the porosity. Porosity means indirectly, if I am telling you the porosity means quantity of space holder that we have used. So these things also we can get from the scanning electron microscopy image. And it can also be observed from the scanning electron microscopy image that interconnectivity among the pores increases with increase of porosity. We can see that, as here you can see in the first image A, that the less interconnected pores are here, less interconnectivity among the pores, as this is 50% porous, 50% space holder I have used here, here 60%, and here 70%. So you can see that more interconnected pores in case of 70%. And as we are increasing the porosity, the interconnectivity among the pores is increasing. So analysis of the data is also an important part. Means during characterization, and you are doing the characterization and analysis. This is the both is the parallel process that you have to do. And from here, the main task of the researcher is starts from here only. Main task. Before that was also important, but the analysis part is mainly important. Now, the micro CT scanning of the foam. So, what if I have prepared a foam? Then we have to be ensure, because in scanning electron microscopy, the surface on the surface we can see that no, the porosity is all right, and the interconnectivity is all right. Yeah, we have got the proper interconnectivity among the pores, and properly porosity we have generated. But what about the inside structure? We have to ensure it also, because when you are going to use it for the artificial bone implant, then you have to be ensured that the porosity should be inside also, because the when it will be used as a artificial bone, then it has to be, it should have the inside porosity, so that the bone fluid that inside our body that is flowing, if there will be no porosity, no proper proliferation of the body fluid takes place, and that will cause a huge problem within your, inside your artificial bone, and that may cause the pain inside your body. And this will not get will be easily integrated with your body. So volumetric distribution among the pores will be obtained by using micro CT scanning. Interconnectivity in radial direction, interconnectivity in the radial direction. Here we can see the top view of this one. So porosity is almost in the every part of the foam. This sample I have taken this one, and also human bone, I have taken it and I have compared it for both with my foam and with the human bone. So interconnectivity in the radial direction, we can also get it from here by using the micro CT scanning. Interconnectivity among the pores in longitudinal direction. Longitudinal direction is also important. And the porosity of the sample, we can see this TV is the total volume, BV is the bone volume. Bone volume means solid volume. BV upon TV is the relative density, means solid part upon total part. So this will give you the relative density. Relative density means what? This is indirectly showing that how much quantity of solid material is here. So left part is what? Left part is vacuum part, means there is only air, that is porous structure. So by subtracting it from one, we can get the porosity of the material. So this is again the another sample, sintered sample, and this is the this is showing that how interconnectivity among the longitudinal direction. So in the radial direction, we have confirmed it through the previous image, and here this is in the longitudinal direction. We can see this one part, and this is how I have seen. I have shown here that with the arrow, that if it will place as a bone implant, then how the body fluid will flow through this sample. So, and due to this porous structure, the tissue will easily get generated within this one, and this will get this will be the integral part of your body easily. It will get easily integrated with your part as compared to the solid one. Initially, the stainless steel plate was used. Later on, the titanium with the solid one, and then porous type of structure. So this is the advantage of this one. So interconnectivity among the pores in longitudinal direction were also confirmed by performing the micro CT scanning of the sample. Now, we have ensured that no porosity is there. We have fabricated the sample. Now, as we have seen in the literature, that Ti2CO, Ti2CO is widely used as a coating element. So now I have added the cobalt as an alloying element by going through the phase diagram. So now we have to be ensured that whether Ti2CO formed or not. If Ti2CO did not form in our sample, then this is totally a meaningless research. So XRD analysis is a important analysis, important type of characterization using which you can ensure that no Ti2CO formed or not by using the JCPDS file, or some softwares are also there. HKL values in material science, all of, if we are from mechanical, definitely. So we have seen that in material science, HLK values was there, and D spacing and all. So by using that D spacing values, so at what angle, what type of structure, JCPDS file, we can ensure that no titanium and Ti2CO formed or not by comparing it with the D values of JCPDS file, or you can directly use the software also. So various formed phases formed after sintering were confirmed by X-ray diffraction analysis, and the X-ray diffraction pattern of Ti2CO is shown in the figure. This is X-ray diffraction pattern of titanium 6 aluminum 2 cobalt. I just have taken the 2 cobalt because this is also the optimized data, and I have also varied the various variation of cobalt percent, and this I have published in Material Science Engineering A. So now, after just we have confirmed it, no, Ti2CO formed. Again, I am telling you that more the characterization you will do, more better you will get confirmed that no, this formed or not. So to confirm this one also, I have gone through the FESEM and EDX analysis. So energy dispersive X-ray spectroscopy was performed to get the elemental analysis of the sample. And it was found that eutectoid phase, as I've mentioned there in the phase diagram, that eutectoid phase nothing but the alpha titanium plus Ti2CO. Ti2CO. So Ti2CO is the same element that we have gone through the literature. We have found that the coating of this one was used. And another is solid solution, mainly consists titanium and aluminum. Two type of phase we can see here. This is the first A diagram here. This is the phases formed after sintering. And this is eutectoid phase, and this is the solid solution phase, this remaining part. Eutectoid phase, if you will go through the some of the literature, you can see that this is the structure of generalized structure of the eutectoid phase. And this is the Ti2CO lamellae. This is the Ti2CO lamellae. This will definitely, this is used as coating element. So this will definitely increase the life of your implant. And this is the solid solution of alpha titanium and aluminum. So overall mapping, overall EDX analysis we have done to ensure that complete the amount of matrix material and alloying element. So we can see here the overall surface of this one EDX analysis. This titanium weight percent is 90.96, almost 91. Aluminium is 6.54 and cobalt is 2.50, and this is almost equal of Ti6 aluminum 2 cobalt alloy. And 6 aluminum also is optimized data, and also this one optimized data I am using here. This is published, I have published in Material Science Engineering C. So this is the this is the elemental mapping of the Ti2CO, this part. So we have to see, we have to confirm whether this is Ti2CO or not. So we have done the EDX analysis, and just 69.858% of titanium and very little amount, very 0.41 negligible amount of aluminum, and cobalt, mainly titanium and cobalt. We can see the major portion is titanium and cobalt, with very approx tends to 0 is aluminum only. And here in the solid solution part, we can see only titanium and aluminum. And how we have named it as solid solution, again, if you'll go through the phase diagram, you can find that no phases will form, no phases formed in that one. So we get ensured that no, this is the solid solution part. And also the by mapping of the first image A, we can see that titanium is distributed in the whole sample. Cobalt is distributed only along the eutectoid phase. Here we can see the brighter phase. This is only cobalt is distributed only along the eutectoid phase region, and the aluminum is this one, the mapping of here this is on aluminum is distributed uniformly. Now to confirm this one, whether the Ti2CO formed, yes, we know that by going through the XRD, yes, Ti2CO formed, we have seen there. And also, I want to say one thing, that no cobalt separate peaks in XRD analysis. In XRD analysis, we can see that no separate peak of aluminum and cobalt we have seen. So this also shows no separate peak of aluminum and cobalt is here. This also shows that either cobalt made intermetallic or get completely made the solid solution. So here also this confirmed here through the this one part. So by going through the transmission HRTM image, this is the brighter field transmission electron micrograph of this one, and this is the SAED pattern. This is SAED pattern, corresponding SAED pattern of this one, this phase. This here is the one corresponding one, and this is alpha titanium, and another is the Ti2CO. Again, by using the D values, we can just draw this one. And this is another matter that how we can draw it. This is a different part. And this is the solid solution part. And this is the SAD pattern of the solid solution part. So we can confirm it by going through the HRTEM image. We can confirm it. So, sir, can you confirm me how much time I have now?
Hello.
Yeah, hello.
Yes, Amit sir.
Yeah, how much time I have, sir? Remain?
Continue, sir. It is
15 minutes more.
15 minutes, no?
Ji.
yeah,
Yeah.
around 15 minutes.
Okay,
Yes.
okay, it's all
Okay.
right. Okay, thank you.
Yes.
So by going through this is the bright again using HRTEM image and SAED pattern, we confirmed it that no, this is the HKL values, and using this HKL values and the XRD in XRD pattern, as we have gone through this this is Ti2CO is 111 plane, and this is the alpha titanium is 022-1 plane, and the same I have got in the XRDD values. So if you'll calculate it, definitely this will match with the XRD data also. This also confirms the formation of alpha titanium and Ti2CO lamely. So by using this much characterization, the more characterization you will do, the more accurately you are just this is like something that you are going in a accurate manner, because more the characterization, more the accuracy in your result, and more the prediction of your result you can get. Now, as I have discussed with you that the whole process, whole sintering process we have done in the vacuum sintering furnace we have used for the sintering process. Vacuum furnace we have used. So proper vacuum is there or not, we have to be sure that so to ensure that no oxide formation took place, so we have done the Raman spectroscopy. So to perform this one, at first intentionally I have oxidized the sample. Intentionally I have oxidized the sample, then we have done the mapping, and on the basis of mapping, then we have seen that between this one, the Raman shift of 200 to 1200, most of the oxide formation of oxide peaks you will found in the Raman spectroscopy in between this one only. So up to 1200. That's why I have selected this one range of Raman shift. After that you can also see that, but up to this one is all right if you are checking the formation of oxide then. So the oxide peaks were confirmed by using the Raman analysis. At first the samples were heated in an open atmosphere, not in the vacuum atmosphere, because intentionally we are oxidize the sample to compare the R sample. So 800 degree for 4 hours. Raman peaks of the oxidized sample and normal samples were obtained at different randomly selected location, and the peaks obtained in both the cases were compared. And also the mapping, because at a certain point we have seen this one, but mapping we have done the surface mapping, then we can see this yellow part is showing the oxide formation. and this is our sample. So we can see here that no yellow part is obtained. So now we are sure that no oxide formed during the entire region. Also in the ADX analysis, no oxygen were as an element we have obtained. So we can also sure that no oxide is not there. Means whatever the procedure we have selected, whatever the fabrication process we have selected, and whatever the allying element we have selected, this everything is going in a well direction. So means process command we have in each and every stage, we have more command on the process. So this is the important part that we are going through. Now we have a sound sample, we can say that the sample we have prepared, this has a good this may have the good property. Now we have to check the property. Means fabrication process almost done, almost we are on the finalization of the characterization. So compression test, and this is the mechanical testing that after that, this one only we will compare the obtained result with the human bow. So the compression test of the foam samples were performed using Indian standard ISO 13314. For this is for the metal foam we are using, and the SWAYS guideline for the metal foam. So the samples were polished and the surface were made flat to avoid any distortion before the test. If you will not polish the sample in a proper manner, there may be bending, there may be some different type of bending action may takes place during the compression or tension, whatever you are doing. So the samples should be polished by using different grades of emery paper, but you should also take care the pores should not be closed during the polishing of the sample. So various mechanical properties were obtained by using the stress strain diagram. I am using here as because compressive stress strain diagram, because compression, the foam mostly you will found that the compressive properties. Also, we can say that in case of metal, approximately the compressive, tensile, or fatigue type of behavior, or I should not say fatigue into this one, but I can say that compression and tensile properties almost same. But in case of brittle type of material, the compressive, these things are different. Means properties will be different. But here also some fluctuations will be there, but not substantially, very minutely on the differences here. So various mechanical properties we'll get from here. So this is the compressive stress strain diagram. So we can see that in the first, this is the first point is showing the initial stage when the sample is mounted. This entire process we have used the camera and we have we have monitored it and during compression test. And this is the stress strain diagram of the metal foam. And we can see that as a cobalt percent we are increasing, so strength got increasing. And this is the compressive yield strength, yield point. This is the yield point. And after that, this is the plastic region. And this up to this one, this is from here, this is the densification region. Means the from here only, from 2 point, this 2 point, after this 2 point, the collapse of the porous type of structure starts from here only. So as the pores will get collapsed, so since this foams is having the air inside this one, so this will produce the cushioning effect. Means air is like a cushion. So this will get smoother type of some smoother type of deformation you can see. But since this is the open cell structure, the open cell foam we are discussing here, that's why some fluctuation we are seeing, fluctuation in the diagram. So some maybe some collapse of the foam, sudden, due to interlocking between the cell wall, the strength increase, again decreasing. So random type of collapsing of the foam. This is causing the mainly these type of stress strain diagram. Now, before the elastic region, load unload curve. If you will load it or unload it, so the slope of that curve will give you the elastic modulus of the material. And the energy absorption capacity, the tough, or I should say toughness of the material, means before it get densified, or in tensile strength, as we have seen in our mechanical engineering also, that up to the fracture point, the energy absorption is called as toughness of the material. So here in case of metal foam, this is up to densification. If densification means what? Each and every pores will get collapsed. If every pores get collapsed, means our sample is totally useless. Means this is we cannot say it as a foam, metal foam. So this is the final point. So energy absorbed up to this point, this is mainly the part of concern. After this one, negligible amount of energy will be absorbed by the sample. So the energy absorption is also the main part. And strength, this is the plateau region. This is like a flattened strength, where strength is not changing, but strain is changing. So this is called a plateau. It looks like a plateau region. That's why it is called as plateau stress. And this is the also important property in case of metal foam. And the compressive yield strength is slightly higher, maybe slightly higher than the plateau stress. So these things are important, and so many properties, mechanical properties you can obtain from here only. So this is also, then again, micro hardness. Micro hardness is an important property, and by using the micro hardness, you can say that whatever the composition you have selected, and on the micro hardness is nothing but the resistance to erosion. If micro hardness is higher, then definitely it will get less eroded as compared to the previous one. So definitely this is the important part of the concern. That's why we have measured it. So the micro hardness of the alloy were obtained by using the micro hardness tester. And since two types of phases formed during the sintering, so we have checked it on the solid solution phase as well as on the eutectoid phase. And we can see that in the eutectoid phase, means wherever the Ti2CO lamellae is there is a slightly lesser size of indenter we will obtain. Means if lesser size of the indenter it has, means it has more hardness. And hardness in the literature survey, if you will go through, hardness and yield strength is directly proportional. So you can see that means strength and hardness is also increasing. The micro hardness values were obtained by using the SOA guideline. Approximately 120 readings per sample we obtained, and average of all value will consider for the further study to ensure that no, because at a certain place maybe some impurity may be there. Due to that one, we may get higher result. So to ensure this one, more and more reading we should take, so that repetitively it should be here to ensure the any property before publishing it. So this is the important thing. This one. Now, whatever the form we have met, and whatever the properties we got, so we should compare it with the human bone. Now the means up to this one, now we have to compare it whether this was a successful result, means research or not. We have to compare it with the human bone. So that's why I have compared it with the human bone also. So this, you can see here that what is the size of whatever the shape of this one. This is the approximately we have achieved the shape of the metal foam also. Here the this is the macropore. MA stands for the macropore. So macropore size, and also you can say that no, maybe some slightly difference of the pore size may be here. So you can also tailor it by tailoring the size of space holder you are using. Means NH4HCO3. If you are seeing that no, this has the lesser size. Recently, I have published one paper on this one only. That what is the size of space holder, and this got published only within 6 days of as I have communicated it, and within 6 days I got the publication. So This is the here we can see that this is the again when I compared it, then this is the shape we have achieved, and here this is the shape, bone wall. This is the bone wall and this is the foam wall. In both the cases, pore and some on the wall and foams respectively. Both in both the cases, some type of these type of structure we can see. And here, this is the cancellous bone. This was the cortical bone, and this is C figure is figure of cancellous bone. This has the three-dimensional structure, and in our cases, this has also the three-dimensional structure, interconnected three-dimensional structure. So we have compared it. Now we can say that no, this has a microstructure of the bone, and present form is all right. This is comparable in. Sir, audio is all right?
Yeah, it is all right, sir.
Okay, thank you. So this both has the a similar type of property, whether this is case of cancellous bone, whether this is case of cortical bone wall, say foam wall, both are comparable in nature. Now we have to compare it with the mechanical properties also. So different type of material with the different properties we have. I just have mentioned here because if I'll discuss in very detail, so it will take more time. So briefly, in the tabulated form, I have discussed it. So this is a different material. This is cortical bone and cancellous bone. Relative density, since it is varying in nature, that's why I did not have discussed it. Because you can say that at the different part of a human body, you can get the different, in the different fraction. Somewhere you can say the 75% cancellous part, 25% cortical part. Somewhere you may say the more cancellous and cortical part. So I did not have mentioned the relative density, but the modulus of range of elastic modulus. In case of cortical bone, you can see that 4.9 to 28. It may some very, if you go through the literature, some one has reported 30 or some may have reported 26, but around this one only. And cancellous bone has range of around 0.1 to 3. Average I have taken here, means somewhere you can see that 0.01 also, but that is a very special case. That is not the part of concern here. And strength is in the range of around 200 plus minus 40, and this is the strength is 2 to 60. Now, the prepared form, in our cases, the Ti6 aluminum 2 cobalt alloy form that I have prepared, the relative density is varying in the range of this one. Elastic modulus, that is the main part of concern. I have got this one range, and this is the amazing range that I have got here. This much 1.83 GPa is the elastic modulus, and this is and up to 41.6. So this is covering the entire range of the, whether this is a cancellous bone or the cortical bone. So this is also, and the strength is also approximately, this is 200 approx, and this is 190 plus minus 15. So approximately very closer to this one. So I have achieved this one strength, and this one this one elastic modulus. So again, I have if I want to do it more further accurate result, definitely I will go for the more change in relative density. Definitely I can tailor it, and so further more parameters, and on the basis of that one we can tailor the mechanical properties. So this was the main part of concern. Apart from this one, I have also conducted the corrosion test. I have also conducted the inductively coupled plasma test, that how much iron may be released. You can go for that one also. So this is the main part that I should say that the characterization part is all about. So this is my publication. I am just not to all the data I've taken from my paper only. So this is my paper. So thank you all.
Thank you, sir. Thank you very much.
Any question, sir?
Sir, it is very knowledgeable and very effectively you have given the lecture. And there is so much thanks from our attendees. There are some few questions attendees have asked. So one of the question is that can we characterize our sample in CSI or EMPRI? Or
Yeah, yeah, we can characterize, but by going through a proper channel, we can do it.
one more question is there, sir. Why tensile strength of foam is decreased or increased by increasing porosity?
Since we are increasing the porosity, if we are increasing the porosity, somehow we are, since the strength is what? Strength is force, strength is nothing but the what? Resistance to, if we are increasing the effective surface area, means somehow we are evaporating the material, means wherever there should be a material, we are just we have just left with the evacuated part. If material will be there, definitely more effectively it can resist. So if there is porosity, means no material is there, only cell wall is there. So it that where it can produce some type of resistance towards the force you have applied. So there is only cell wall is there in place of the whole sample. So strength is decreasing due to the effective surface area is decreasing.
So next question is that where we can test the aluminum foam material in Bhopal.
Aluminium foam,
Yeah.
yeah, we can test it easily. We can. In fact, aluminium foam has very lesser, strength as compared to titanium one. So you can easily test it because aluminium has very lesser strength, I think, as compared to titanium. And one have asked, the foam you have made is functionally graded. Yeah, we can produce the functionally graded material foam. Because functionally graded means what? Means we have a range of porosity within the same foam. If you are using it as means a range of space holder, if you are using, then definitely you are producing like a different pore size within the same foam sample.
Okay.
So definitely, if you have a range of porosity, so you can produce the functionally graded type of foam structure.
Okay. Thank you, sir. I would like to Ghanshyam Satnami sir for word of thanks. Please, Ghanshyam sir. Audible, sir, it is.
Okay, sir. I am audible.
Okay.
Good afternoon to all. I am Ghanshyam Satnami, Assistant Professor in the Mechanical Department, and I am here to present the vote of thanks for today's workshop. I would like to thank our guest workshop speaker, Dr. Amit Afaz sir, for visiting and enlightening us with their knowledge. Today's workshop was full of knowledge and interesting things. It gave deep insights into the topic and also it revealed some interesting facts. The point where Dr. Amit Awaz told us about the selection of material really informative. Once again, I would like to thank Dr. Amit Awaz sir for taking out time from their busy schedules and enlightening us with the knowledge. Thank you so much, sir. I would like to also thanks our Dean sir, HOD sir, panelists and attendees, and also thank you to all students present here. Thank you so much, sir. I would end my speech here. Thank you, sir.
Thank you, Amit sir. Thank you all the panelists and attendees for giving their valuable time for this lecture. I also very thanks to Dr. Amit Abbas sir for their valuable knowledge. And also I request to Amit sir for if our students, if our university students wants to attend any training programs in CSI or MPRI, so he would definitely help for them.
Okay, thank you, sir. Definitely.
Thank you very much, sir.
Okay,
Thank you, sir.
thank you.